Ready to effortlessly conquer those tricky statistics problems? Meet ShinStats. Picture having a personal statistics wizard in your pocket, leading you step by step through the toughest questions. Hey Nixers! Ever felt ensnared in the intricate web of decision alternatives? Today, we're about to unravel that mystery. Join me as we select the optimal course of action utilizing the maximum expected monetary value. Additionally, we will calculate the cost associated with obtaining perfect information about the states of nature. All right, Nixers, got a question for you. Now let's proceed to the calculator and crunch the numbers. Begin by launching the app. Head to the menu bar and click on it. And here's a quick pro tip. To make things even easier, use the search bar. Just type EMV and it will lead you straight to the calculator. On the calculator's landing page, we will be asked to input the number of rows and the number of columns associated with the payoff table. In consideration of the given table below, that has 3 decision alternatives: bonds, stocks, and mutual funds, and the 3 states of the economy. Growing, stable, and declining, we input a 3-row by 3-column payoff table. Next, since we are asked to utilize the maximum expected monetary value in finding the optimal decision and calculate the expected value of perfect information, this gives us the hint that our decision analysis will involve probabilities or risks. As a result, we select with probabilities in the drop-down menu. Moving on, we populate the payoff table with the corresponding column and row names, then proceed with providing the values. Remember, accuracy is the key. The app's magic works best with precise data. Now, we're ready to unleash the statistical wizardry and proceed with the identification of the optimal decision. With everything set, we now click Calculate and wait for the app to do its magic. Interested in downloading the app? Link in my bio. All right, Nixers, let's delve into the step-by-step solution. We'll walk through each phase, providing a sneak peek into what the calculator churns out. In step 1, we add a new column and label it as EMV. In this column, we calculate the expected monetary value associated with each decision alternative. To facilitate this, we turn our attention to each row and multiply the payoffs of each state of nature to their corresponding probabilities. For example, the expected monetary value for bonds will be 40 times 0.2 plus 45 times 0.5 plus 5 times 0.3, which is equal to 32. In other words, the expected profit of investing in bonds, taking into account the probabilities associated with each state of nature, is equal to 32 units. We follow the same procedure to calculate the expected monetary value for stocks and mutual fund, which are calculated as 25.1 and 31.6, respectively. Here are the summarized results. In step 2, we identify the highest value in the EMV column. In this case, among the 3 values, 32, 25.1, and 31.6, the maximum EMV is 32. In step 3, we identify the decision alternative associated with the maximum EMV, which is bonds. Therefore, in step 4, where we formulate our conclusion, we conclude that the optimal decision using the expected monetary value criterion is to invest in bonds. In step 5, we now start the groundwork for the calculation of the expected value of perfect information, or EVPI. To do this, we need to establish that the maximum EMV, which we have calculated a while ago, is equal to the expected value without perfect information, or EV without PI. As a result, EV without PI is equal to 32. Next, in step 6, we calculate the expected value with perfect information, or EV with PI. To do this, we look for the maximum payoff in each of the state of nature columns. As a result, in a growing economy, the maximum payoff is 70. In a stable economy, the maximum payoff is 45. And in a declining economy, the maximum payoff is 5. After identifying these maximum values, we then multiply it with the corresponding probabilities. As a result, we have the following calculation and end up with an EV with PI that is equal to 38. In other words, this is the expected profit if decision makers have complete and accurate information about the states of nature, enabling them to make choices that result in the highest possible payoff for each decision alternative. Lastly, in step 7, we can observe that to be able to calculate the expected value of perfect information, we just subtract EV without PI from EV with PI, which results to a value of 6. This means that the expected payoff could potentially increase by 6 units if perfect information is available. Can I interest you in an opportunity? Leverage our handy calculator to guide you to further understand the process of these calculations. For an added twist, compare your own calculations with the results generated by this calculator to facilitate a thorough cross-check. Drop your answer in the comments. Your input is the key to knowing if we're making a real impact. Let us hear your thoughts. Did those results light up a spark of curiosity in your mind? Show some love with a double tap or hit that like button. If you're itching for more data-driven excitement, click the link in my bio to download the app from the Google Play Store. A heartfelt thanks for sticking with us till the end of the video. See you on the next one. Follow for more.